Okay. I'd like to work a couple of Charles Law problems. We'll start with number 1. A balloon inflated in a room at 27 degrees C has a volume of 5 liters. The balloon is then heated to a temperature of 75 degrees C. What is the new volume if the pressure remains constant? Alright, so we have an original temperature, T1, and an original volume, V1, and then we have the new temperature, T2, and we're asked for the new volume, V2. So remember, we want to list our givens first, write our formula, rearrange our formula, and then plug in our numbers and units and solve. So we'll start by listing our givens, V1, T1, V2, T2. Our V1 is 5.00 liters. Our T1 is 27 degrees C, and please remember to immediately add 273 because our temperatures always have to be in Kelvin. So we add 273 to our degrees C to get the Kelvin, and that makes it 300 Kelvin. Our V2 is what we're looking for, and our T2 is 75 degrees C plus 273. We get 348 Kelvin. So our formula is going to be Charles's law, which is V1 over T1 is equal to V2 over T2. And we want to solve for V2. So let's hold V2 where it is. We're going to move T2 to the other side, which means we're going to multiply both sides by T2. That moves T2 up. So it's going to be V1, or V2 is equal to T2 times V1 over T1. T2 moved up. Plug in our numbers. T2, 348 Kelvin. V1, which is 5.00 liters. And T1, which is 300 Kelvin. And it doesn't matter where I put it down here, as long as it's on the bottom. Cancel our units. Kelvin cancel out. Liters are left, which is good because we're looking for a volume. And so we have 348 times 5. Remember, we multiply across the top and divide by anything on the bottom. So we're dividing by 300. And let's see, we've got we've got two significant figures, so works out just fine. 5.8 liters.